Good evening, everybody. Welcome to our regular SOAREX meeting. Before we get started, read the disclaimer. Please note that all our meetings are recorded and made available to the public for viewing on our YouTube channel. By participating in the meeting, it is understood that you have accepted these terms. With that out of the way, so tonight, um, Michael is going to talk about his automatic antenna switch project. And then we're going to be starting the topic of interest. And I think Peter said he was going to lead this one. So, Michael, whenever you're ready to go, go ahead.
I don't hear Michael. Oh,
Michael, you're muted.
Muted. Okay. So now I'm going to bring that back, and I'm going to start the presentation, start the sharing. Okay. There. So you should be able to see that, right?
yep.
And
Yes, sir.
if I go to full screen, you can see that, right? The background page? Okay.
Yeah.
So anyway, all right, let's go. This is the background here is that a bunch of guys in the Mississauga Club decided to build an antenna, and a remote antenna switch, and it's low cost, and it was designed. Published in April 2005 in QST, and low cost antenna switch by Bill Smith, K04NR. We built 8 in the Mississauga Club, and in 2022, Daniel V3NI and I decided we would build an automatic switch. And we have a working breadboard, and it needs some modifications to simplify things, and then it has to be packaged into a box. So this is the design from the 2005 article. Let me see if I can get the my pointer thing here. Show pointer options, laser pointer. Yeah. So it's a 6-position switch. So there's six altogether connectors on the board. Each one, when you put 12 volts to it, turns on a relay, which is protected by a diode in case of surges, and that turns on a connection to the input here through this line. This is a normally closed switch, so when you apply power to it, it goes normally open, which connects this antenna to the RF input. And all 6 of them are designed so that if they're not if they're closed, like if they're not energized, they're grounded. Like you can see the ground here. So this is the FAR circuits board. You can get the board at FAR circuits still, remarkably, after 15 years, 18 years, I guess. The board is still available. This is what it looks like. It's got places for the six relays and whatnot, and diodes. That's what the assembled board looks like when you finally build it. The issue in building one of these things is getting the diodes are here, and the terminals are here. The issue when you build it is making sure that things are all lined up. There's the box that we built it in, one of the boxes. This is how we lined them up. We basically measured very carefully where the SO239s had to be, and made a little board like this to hold them in place for soldering. And we drilled a template out of 1/8 aluminum, I guess it was. And this is what the switch looks like when it's new and pristine. This is mine. and this is where it's mounted on the tower. So this is the circuit that I designed to control this switch. These are the six antenna connections here, and you apply 12 volts to those through half of a 6-pole or 8-pole, whatever it was, a rotary switch here. The other half of the switch supplied LEDs on the front panel of the box, the control box, and that's what it looks like. And you'll notice the artistic design here, artistic license, which means they're not all lined up. That's to keep you awake. But anyway, so that's the little box, and it has, in my case, it has a tendency to slide off the back of the rotor controller. So I'm looking forward to a newer box which can be bigger. Anyway, so why would you bother automating this? The switch control, well, to avoid connecting to the wrong antenna is the reason. Very easy to do, particularly using FT8, for example, because with the cat control from the radio connected to the JTDX program and the logging program and all that stuff, when you change a band in the JTDX, for example, you want to make sure that you're not connected to the wrong antenna, and this is how you automate. This is how you solve that problem. And it's done by using the band output data on the back of the relay, on the back of the radio, and that you use that to switch things. And I'll go into that. We built a breadboard circuit, a working breadboard circuit. It has to be, we're going to simplify it, and that's the next step. And then we'll be able to put it in a case, some kind of enclosure. So the way the thing works, it takes the transceiver output, the ABCD output, puts it into a BCD10 decoder, in our case a BCD10. The output from that goes into a relay board, and that's supplied with 12 volts. And the board also drives an Arduino, which the purpose of the Arduino is to drive an LCD display. And there's a manual bypass, because bypassing the automatic system, because if you have antennas that, if you got more than one antenna for 40 meters, for example, you might want to select one or the other, and that's what the bypass is all about. So this is the BCD decoder. It's got the band data on the MP looks like this. It's the FT1000 MP. It's a round connector, and it's got 4, 5, 6, and 7 are the ABCD data points, and those go 5 volts or 0, depending on which band has been selected, and there's a combination of those. And the BCD decoder board, this thing on the right, you connect the ABCD connectors to the bottom here, and what it does, it converts the output. These are the output terminals. It converts, for 80 meters, for example, it takes say the 80 meter point, which is here. It takes that from 5 volts to ground. So normally that's 5 volts. So when the 80 meter antenna is selected, it takes it to ground. And in my case, because I've got one antenna that's got 10 through 20 meters, I've got all of these pins 10 through 20 in parallel. So they all go to ground, or any one of them does. So that way you make sure that you switch the right thing. So it grounds the selected input. And this is the table. For example, 80 meters here, pin B is high, the rest are 0. 5 volts, the rest are 0. 40 A and B are high, the other 2 are 0, and so on. So that's how all that works. And this is an 88-channel relay board. On the bottom of the board here, there's the inputs, and these are held high by the by resistor to 12 volts here, and 12 volts. And when the BCD grounds one of these pins, it goes low, and it turns the relay on. And on the back here, this is the normally closed contact, this is the middle contact, and this is the normally open contact. So you connect your 12 volts to here. and or rather you supply 12 volts to here, and you connect your antenna to this pin, your antenna cable going up to your antenna switch rather. So we use another board to drive the display, an 817 module with four terminals. This takes 12 volts to 5 volts. Basically what you do is you put your 12 volts on here. If this thing is active, you put 12 volts on, otherwise it's floating. You put 5 volts through a resistor. Internally, there's a resistor in here that keeps this pin high unless the other side is active. And how that works internally, it just turns on an optocoupler, which basically turns a transistor on, which grounds this point here. So this point goes from 5 volts with nothing happening to 0. So the power connections, depending on what you want to do, you've got a bunch of LEDs and stuff, and the automatic or manual switches here. This is going to change in the new design, make it simpler. This is the decoder board is here, showing the connections, and these are this is the output from, let's say, the 10 through 20 goes here to there, and then when any one of 10 meter through 20 meter antennas band gets selected, turns this on, turns the relay on, connects 12 volts to the cable going up the outside the house and up to the antenna switch that turns the relay on in the relay box up top, which connects that antenna, removes the ground and connects the antenna to the coax. And the manual switching, similar stuff, same idea. There's a rotary switch that does this. Is the current implementation. This is going to change. And we have, and the going back to the automatic system, the output, I'm going to go, the output from the 817 goes to the Arduino display, and the programming is set up so that it shows automatic, and then it shows the particular antenna. So there's 2 lines in it. Daniel will talk about that. But so basically that's how that works. You need to have another relay here when you go to manual mode, because you've got to make the display stay manual, and that's what this thing does. It's programmed that way. So I'm going to turn it over to Daniel at this point to talk about the rest of it. Go ahead, Daniel.
Yeah. So before we get going, are there any questions for Michael and what he's presented so far?
I can't see the questions without coming out of sharing, by the way.
Oh, okay. Well, go ahead, Peter.
Pete.
Yeah, Michael, just to make sure I understand, if you're using the one antenna, say, for 3 different bands, how do you hard code into the software, like the information for what antenna is to be used for a particular band?
I wonder if I can go. Oh, I can go back here. Good. Okay. What you do on this board here, there's one. You set it up so the my one antenna has 5 does 10 through 20. So what you do is you take all the outputs from the BCD for the 10 meter through 20 meter antenna, you feed it into one relay. Okay. And that relay turns on the particular, in my case, a mini quad up on the tower, the 5-band antenna on the tower. That answer the question?
Yep. Thank you.
Any others?
One more, Michael. One more.
Yep.
When you guys were making the chassis, did you do it as a group so they were all the same kind of thing, or did you do it like individually?
We did it at my place. We did everything at once at my place.
Okay.
So a bunch of us in my basement, and I have a tap and dies thing which we use to make nice holes in the box and everything.
So everybody so the LEDs on your panel are all the same.
Well, no, actually, no. Actually, I was talking about the box outside. I wasn't talking about this very pretty box here. I think that's kind of nice, don't you?
Yeah. Oh, yeah. Well, I originally was talking about the other chassis, but I slipped into this one. I couldn't help myself.
This one. Yeah, we did all these at once in my basement.
Thanks.
And having made that little template thing, that was really easy because you just attached You
Yeah.
attached the one on the bottom. You screwed it in a top right and bottom left onto the box, and you just drilled your holes, all of them, and then these things all lined up nicely. And this is down the bottom here. This is the chassis punch thing we used to do it. So okay, any more? No more.
Dave.
Oh, Dave. Okay. Yep. Dave.
Yeah, Michael. Sorry, can you hear me?
Yeah, we'll show you here. Fine.
Yeah. Okay. My computer crashed and I missed a fair chunk of your presentation, so I may ask a question which you actually talked about. Is the connection? This is a remote antenna switch, I take it, and do you have a control cable?
Yeah, how it's
to it,
done. How
or-
it's done is there's the box outside with the 6 relays, and the control comes in through the Molex connector in the back corner here, the set on the roof.
So
And
it's an outer band. It's an outer band control cable.
it's 12 volts DC. Yeah, it's
Yeah,
a 12
it's
volt
a
input.
separate. You're not sending the control inputs across the coax. You have a
No.
separate cable.
No, this is a separate cable.
Okay, that's
how I did it.
Okay, is there a reason why you did that? I guess it's just the design.
Well, this was the design of the box, and it was just simple. Oh yeah, I got the design came from. I'm not sure if you got that. The design came from this guy Bill Smith in 2005 in April 2005 QST, and this is the box, the design with the six relay connections, and these are all set up so they're normally grounded. So if the particular antenna is not being connected, this is open. It's only connected to the input when the relay is active. So this is the design they used. This is an easy way to do it. At the expense of cable, of course, but no fooling around with chokes and using coaxial cables to transmit data up.
And you have no issues with ground loops having
No.
a second, because I think I saw a picture you had some optical isolators.
Oh yeah,
So
okay.
is that-
So where are they here? Let's see, where did I have that in here? The short answer is no. There's no issues because internally they're all. This is the BCD decoder, and this is the opto isolator that turns it on, and this is connected the relay on, and this is connected to one of these terminals by whichever one you use. So it isolates what's going on in the 12 volt supply in your house from your power supply. It isolates it from the antenna connection, which is here. That's what
okay, check. Yeah, that's what it
does.
using opto isolators so that you don't have another ground going out to the antenna.
That's right.
Okay, that's it. Thanks.
Okay. Okay, Daniel. Anybody else? Guess not. Go ahead, Daniel.
Okay, very good. Well, first, let me introduce myself. I know I've met some of you before. My name's Daniel Goodyear, VE3NI. So this really was a project just waiting to happen. But just to put some context around it, I had purchased these BCD boards about 10 years ago or 8 years ago. And with the idea that one day I would like to try and automate a remote antenna switch. In this case, Michael has his antenna switch that they built as part of the MARC Club the year before I joined. And I have the ICE Communications six antenna switch. So we wanted to choose or develop something that we could both use and that would meet both our needs. You know, very simply, we just need to replace the manual rotary component because the remote portion is just a set of relays that we didn't have to worry about. So also, we decided to make it Arduino driven, use a small microprocessor, and those are the kinds of things I like to do. I've been involved in IT for 45 years, and it was I just like taking and doing some programming. In addition, Michael had the more electronics knowledge. I know enough electronics to be dangerous, or as Michael will always point out, enough knowledge to build a QCX, create a short in it, not being able to find it in the last 2 years. So we decided to take this project on. And so we started doing all our development on an Arduino Uno. Oh, did you want to go to the next slide, Michael?
Yep. There you go.
Yeah, so as Michael mentioned, really the only purpose of the Arduino is to handle the user interface between the unit and the human being sitting on the other side. In Michael's previous case, and in my case, all we have are on our current switches, of course, are a set of LEDs. It being the 2020s, we decided to use a small LCD screen. And again, it was just another fun thing. This was really a journey of discovery in trying to program these. And when it really comes to it, it's not all that difficult. Next slide, Michael. So this is, in completeness, the whole Arduino sketch, all in Michael's case, 94 lines. So it is very, very simple. We have defined a number of pins that are digital inputs. We just want to find out whether they're high or low. And in addition, we want to have one pin that is set to high or low depending on whether it is in automatic mode, which means it's taking the readings from the BCD board output from the radio, or if we're using the manual switch. Both Michael and I have different antennas, and it could be that I happen to have a 40 rotatable dipole, a Wark rotatable dipole, an old Mosley 10, 15, and 20 Yagi, but I'm looking at possibly switching it up and putting in some other putting in another antenna. So we wanted to make sure that if we had the case where we had either multiple antennas, be that 2 or 3 that had the same band, we wanted to be able to use, let's just say, 15 meters that might be on the Yagi or might be on the vertical if that was connected up. And the way we decided to do that was to have a manual mode where we could then go and specifically use a specific antenna, which in automatic mode might be used on one band, but also was capable of operating on a different band. So, basically, it couldn't be simpler. It really is a pretty basic. We set some initial variable settings. We do all our definitions, define some initial settings, and put everything into a known state, and then we just loop. And I couldn't believe how easy it was. The first thing we want to test for is the radio on. So we set no radio to 0, and if we find any instance where a pin is set low, which means that relay has been set, then we add 1 to it. Therefore, at our last test condition, the radio is there. If no radio is low, which means it's 0, then if it's 1, if it's still 0 at the end, that means we don't have anything connected. But if it's 1, then it just ignores it. And then all it does is for the various pins we've defined, it just says, is it low? If it's low, then that is the band we're setting, or that is the antenna that we're going to use. And for each section or each paragraph, if the pin state is low, all we do is we state on the first line whether we're in manual or auto mode. And then on the next line, we set we just put a string and tell it what antenna are we using, and you have the ability to go in and change the values. It's what I call it's just a brute force method. There's nothing simple or elegant. I could put these into arrays, have pointers to different arrays. I could condense the lines, but the reality is with 94 lines, we weren't even approaching, I think 9% of what we had available to us. So it didn't really see any benefit in making it more compressed. And ultimately, well, I am the programmer, I wanted something where Michael was able to go in, or anybody else who uses it is able to go in and look at it. And because I believe in a lot of self-documenting. It should be self-describing the code, and in this case, I think it is. So I didn't want to. So I don't want to make it obtuse. I want to make it as straightforward as possible. And that's it. The only limitations we have are the number of relays we have, less the one relay that we use for. Sorry, it's not relays. It's the number of on the 817 on the modules where we take 12 volts and convert it to 5 volts so the Arduino can read it. That's the sort of limiting factor. That and the number of relays we have as to the number of antennas we can drive. Okay, next slide, Michael. So it then became a question of, well, the Arduino Uno, there's nothing wrong with it except it's a little bit on the large side. So what, the next question was, well, which microprocessor did we want to use? Now, we were, to drive an Arduino, it takes 5 volts, or I believe you can do it with 3.3 volts. But what we have is a number of other modules that operate at different voltages, whether it's 12 volts, 5 volts, and we're sort of feeding these modules, and I don't like taking 12 volts and necessarily converting it to 5 volts, or at least I don't feel comfortable in creating that electronic bit. So what we did, or when I was looking at these, I noticed that Arduino.
Where'd you go?
I'm sorry about that. I appeared to have been dropped.
Yeah, okay, Daniel. I'm just gonna start the sharing again then. Hang on, let's let me get it started.
Yeah, well, you can start it. So what I was
hold
concerned
on,
about,
Daniel. Let me get it started.
Well, okay.
There you go. Okay.
Yeah, so my concern was when you go to feed this, we're going to feed the whole box with 12 volts, and then that also powers the BCD, that powers the relay, and I want to power the Arduino. So I noticed that there was an Arduino Nano called the Nano Every. And one of the nice things I liked about it is that the power input was actually 7 to 12 volts. Or was it 7? No. Where is it?
On the bottom here.
Yeah.
Right there.
7 to 21 volts. That's it. So it gave us a latitude of voltage it would accept. You want to go to the next one, Michael?
Yeah.
So again, this was when we did this presentation for the Mississauga Club. We just wanted to show the relative sizes in the boards. The next one. So here it is in its carrier board. So again, I also like screw downs. So you can see that at the bottom of these carrier boards, which are designed by a gentleman in Calgary, it has the power feed on the bottom of the board, and then it basically exposes all the pins along the side in a screw down format. So I like this because it would be simple that when we do put it into a box, we can screw it down, we can mount it in the box, and then rather than doing soldering, we can actually screw things in so everything's tight. I don't like using the jumper pins on the Unos in the sockets on the side. I'd rather have something in there that's relatively more permanent. Okay, Michael, next one. So as Michael said, this is the everything breadboarded. And I'm not sure, Michael, did you want to go through and describe
Well,
all the
okay.
components?
This is a really handy little board for holding things. Like it's what's it called, Daniel? This thing?
I can't remember.
It's a vise anyway, and the boards can fit in here, and you can hold stuff. So this is the VCD controller with the cables coming out, and they go over here to the relay board here with the eight relays. We're only using 6 because we only got 6 antennas maximum. At least that's the design for the of the one I have, so that works. And this little LED lights up. This means the my mini quad antenna is set. And on here you can see just barely it says auto and it says mini quad MQ36R. So this is the 817. Excuse me. And because the relay is connected, or the VCD is saying the radio is actually on 20 meters, let's say, this relay's lit is on. That's what that means. And right now you can't see here, but when we were originally designing this, we were turning LEDs on instead of actually physically connecting to an antenna because we didn't have things set up. So we had four LEDs, one for each relay and one for each antenna. So you could tell it was working basically. And this is the 817 that converts the 12 volts on this side to the 5 volts. Here it's supplied with, these things are high at 5 volts. And if the relay gets, if this optocoupler gets turned on because it's on a particular antenna, it grounds the pin on the nano in here, grounds the appropriate pin, which makes the display, it's going through the loop and it makes the display say auto and it makes it say the mini quad antenna. And at this stage we didn't have the manual connection, but there was a switch in here someplace as well, which we didn't have set up. So I take it you'll appreciate the nice clean design here with all the stuff. Okay, Daniel?
Very good. Were there any questions on this picture?
Hope not.
Just one, but it's going back a bit. I apologize for that.
Oh, let's go back. Relays, go back? Should I go back?
No, the picture's fine. The relays that you've got there, what sort of model are they? Did you have to do any RF compensating to? Oh no, they're not driving the RF. They're driving the remote relays in the box. That's right.
Exactly. That's exactly
right.
what they're doing.
Right. Yeah. Pardon me.
Okay.
Okay. So now that we've sort of have it breadboarded, our next step, and as you know, we had actually started this, I guess, in last March or something. I just retired 6 weeks ago. So now I thought I'd have more time to work on this, but that's farcical. You retire, I'm just busier now, just not getting paid. So our next step is we're looking for an appropriate project box to put this into. And these are just sort of conceptual pictures of what we're thinking it will look like. So, looking at it, we're thinking of a push button for power. If you put it on, there would be a green LED that would turn on. In my case, I've got a heater button, which means I got a small ceramic up in the remote portion to heat it up if anything, if it gets really cold. Again, if that gets pushed, we'd have a red LED. We have the display. over on the top right-hand side, if we push a button there, we'd have a red LED that would put it into manual mode. On the back, we're looking to drive this with some standard power poles. It shows a strip there, but chances are that'll probably be some sort of 9-pin Molex connector. I like quick connects. And then the BCD input, Michael's coming from a Yaesu using the DIN connector. I have a Elcraft, so in my case, it'll just be a 15-pin sort of VGA type connection, and I'll just be using a VGA cable between the two. So that's those are sort of the parameters of what we need to do or need in our box. I want something that is fairly straightforward with a little bit of room so we can go in there and change things if we have to or fix things. All I know is that whether I'm running not even FT8, but if I'm running CW or heaven forbid on phone, I'm still forgetting to switch my antenna now and again. And I'm putting it down to aging, but I think this will be one step to mitigate that. Okay, and I think that's the last slide, Michael.
It is. If I might comment, one of the things we're going to do this ugly construction style with some kind of haven't really thought about whether it's going to be a copper clad board or something we can attach the sort of the BCD and stuff to, and just basically point to point wiring it. I've sort of thought about the idea of using KiCad to do some kind of fancy PC printed circuit board to do the wiring. We really haven't thought a lot about that. That's just a vague idea at this stage. We may do that eventually, but if we start with some kind of board holding the BCD on standoffs or something, we can play around with. We can at least think about doing something with KiCad. It may not be necessary, but it's just a thought. Doing some kind of PC board thing. But I don't know whether we need to bother or not. It works with the point-to-point stuff, so we may just leave that. Anyway, that's really all we have to say. Any questions? Any more?
Go ahead, Howard.
Yeah, good presentation. I'm kind of new to this, so I was just curious. The BCD output from the radio, so the radio does all the work, and it just outputs a high or a low signal at a particular pin, depending on what band the transmitter is selected to.
That's right. This is the logic table for the input and the output. So the the ABCD numbers columns here are what you're providing to the BCD10, and the radio puts out where the 1 is 5 volts. So in 160, it's 5 volts on pin A and 0 on the other 3. On 80 meters, it's 5 volts on B only, and 40, it's 5 on A and B, and so on. So that's how it works. So the radio provides this information at 5 volts and gets fed into the BCD, which goes into a couple of ICs and a couple of auto isolators and whatnot. And then on the output pins, which are, where are they? I can't find it now, but yeah, so the inputs are here. So you connect your radio ABCD to here, and the board does the rest. And it just basically these pins are, if there's nothing connected to the output pins here, there's 5 volts here. When you select a 80 meter antenna, the 80 meter pin here goes to 0. Right. And you use that to drive the relays opto isolators. That's how it works.
Right, I see. So any radio that has a BCD pin or a connector, is it a standard or is it different?
Yes, it is. It seems to be, at least for the. I'm only familiar with the Yaesu radios, and Daniel's Hellcraft has the same. It's got the ABCD outputs. The MP has it. The FTDX 101D has it. 101MP. All the Acer radios are done this way.
Okay.
And
Good.
Elcraft presumably also I would think ICOMs are done this way too. I don't know, but I presume.
Yeah.
Well, I think the question is that most newer rigs, like for example, I don't think my Kenwood TS940 had a BCD output. So it's a generational thing with the radio. So probably anything in the last 10, 15, 20 years probably has a BCD output on the back of it.
Well, I bought my MP in 2000, so it had it in 2000.
Okay, good. Thanks.
Okay.
Go ahead, Pete.
Yeah, I just wanted to go back to the reasons for choosing the Every over the Nano, mainly because I thought the Nano would do the job, and the price difference, the Every, I believe, is quite a bit more expensive than the Nano. So, what was the reason for going that route again?
Yeah, it was basically the fact that we wouldn't have to really be too concerned about what voltage gets put into the microcontroller. It was me basically saying chicken shit on having to build anything extra. We can just feed it directly. So because we're going to be taking 12 volts in, we'll be able to split it off to everything and not even have to worry about it.
Okay.
That was the main reason.
Okay, thank you.
Yeah, I mean, and you're absolutely right, Peter. The cost differential, because the Every is a Arduino product, it's got the name brand cost rather than going to Universal Solder and picking up a $5 or $6 Arduino. So it is different, but it was just because of that one specific thing that I was concerned about.
Anybody else? A question? Go ahead, Dave.
Yeah, I just noticed something on that chart. I don't know. Can you zoom in on that chart there, Michael?
Let me try. Let me see if I can go to get out of.
Because I'm looking at the memory for it's the Every board,
Yeah.
EVRY,
Yeah.
versus the Nano. It's got more flash, more SRAM, but it looks as if it's only got 256 bytes of EEPROM. Is that correct? Versus
looks like
the
2568. It looks like to me.
2568.
Yeah.
That's kind of wonky because it's got to be at base 2, right?
No, it's 256.
I can't zoom in on it.
256 bytes.
Yeah.
Yeah, that's a not a lot. So if you want to store persistent data, you only got 256 bytes versus 1 kilobyte, 1K for the Nano.
Yeah, well, even when our program compiles, it's taking less than 9%.
Well, no, that's flash. That's EEPROM, though. EEPROM is for like persistent storage. If you're going to keep your own storage persistently, that's got nothing to do with the flash or SRAM. Now, I didn't quite understand what you said about the voltage. I'm sorry, I didn't get. You're saying that you chose this because you wanted to use 12 volts, and I didn't quite get what you were saying.
Yeah. So, in my case, we're not giving nominally that 12 volts is what it's expecting. All these will accept 12 volts, except that my power supply is probably putting out closer to 14, 15 volts. And I was concerned about that. Maybe I didn't have to be, but I was more concerned about not having to worry about regulating the voltage.
I don't understand. Are you saying that the Every board, if you plug in 14 volts, it's going to regulate it, or you're providing?
No, well, according to the specs, it'll take 7 to 21 volts, so it is regulating it somehow.
Okay, that's the part I missed. I didn't catch
Sorry.
that. But you said it goes up to 21 volts, and the Nano doesn't.
No, the Nano. Hold on, I got the presentation here. Yeah, the power, the nominal input power is 7 to 12 volts.
Oh, okay, check. Okay, I understand. That makes sense.
Yeah, actually, the
Okay,
Nano's
thanks.
the only one. Yeah, the Nanos, all of them are 7 to 12 volts, with the exception of the Every, which is 7 to 21.
Okay, check.
Okay, anybody else? Question or comment? Nope. Good. Michael, Daniel, excellent presentation, guys.
Great. Okay, thanks. Yes, Peter.
Yeah, I did have one. I almost forgot. I was going to ask about the heater. I heard a mention of a heater out remotely. What's going to be the deciding factor? Are you going to leave it on all winter long, Daniel, or just during certain temperatures, or what's the idea there?
No, it's just if I find that it's not working, I'll turn it on. No, in fact, I've never used it at all.
What are you using? Are you using just like a small little heat trace kind of thing that runs on 12 volts, or?
Yeah, it's just a ceramic heat block. Now, what I have is a commercial product by ICE Communications, or ICE, and so that was just one of the features. I thought, it's there. I want to retain it. I mean, I was first licensed in Edmonton, and I've had many times where I've had a rotor, just sit up in one direction until it unfroze. So,
yeah. I got you.
Not that this would help it, but I got away from that by just going to a SPID. So,
Lauren Jackson, VACCXT, lives here as well, and he has a heater in his rotor, in his antenna switch, uses it all the time. I think has it on all winter. I think just to keep it dry, I guess. Keep the moisture out, maybe.
Yeah, well, he has the same one I have, but with 2 additional antenna ports.
Mm-hmm.
Just on the signaling out of the rig, you say it's ABCD?
Yep.
Yeah, I've got a Kenwood, the 590, and I've got the manual out, and I'm looking at all the accessory jacks and what the manual says their functions are, and I'm not finding that. I'm wondering if on the Kenwood it's a serial.
You could have a look at, is there maybe there's a section in the manual where it talks about amplifier connections, because you have to be able to control the amplifier somehow, and that's how, for Yaesu anyway, that's how they control the amplifiers, their own Yaesu amplifiers using that. Maybe it's there, I don't know. Could be it's a different way of doing it.
Yeah, I've got a linear here, and I've worked. I had a 450, which actually the Kenwood kept the same connections for a linear, and there's no, at least to hook up a tube-based linear. You've got your ALC, your RF connection, and your PTT and your ALC, but there's no. It's probably there, but I'm just wondering if Kenwood does it, if it's serial data.
Could be, yeah. Could be. I don't know.
Yeah. Okay.
I think Dave had his hand up.
Nope. It was an accident. I was just trying to send the applause.
And, is that what it was?
And every time I tried to send the applause, they would put my hand
there's
up.
one. Looks like a foot to me. Oh, no, it's a hand. Okay.
Okay, anybody else? Okay, once again, guys, excellent presentation.
Oh, thanks. That's good to know.
Look forward to the finished product.
So am I.
Yeah, me too. It's been a long road, and it's a long road to go yet.
Yeah. Okay. You want to take over, Peter?
You don't want to carry on? Okay. Well, tonight we thought we'd start with a topic of interest. Topic of interest, when we did our poll, scored quite high on our poll. So, which brings me to say, if anybody has any ideas for topic of interests, please start posting them so we can capture it, and we can start putting a list together, and we can carry on with it. So tonight there was a suggestion that we talk about the solar eclipse QSO party. It's a NASA-supported citizen science event, and HAMSci is also involved as well. And I think I put a link for the HAMSci information on it. Anyway, tonight I thought maybe I'm not sure the best way to do this, whether just do hands up or do a round table, and everybody just quickly express their views. Although we've got a fair bit of time. Dave, you got something to say?
Yeah, if you want, I could kick it off. I've got a suggestion.
Oh, sure.
Something simple.
Yeah. Go ahead, Dave. Yeah.
Because in my style, I always do a power slide. So can you see my screen?
Yep.
So this is what I was thinking. Something we could do. Yeah, you could go by way of HAMSci. Yeah, that's an option. We could do something like that. But for us internally at our club, why don't we maybe set up some of us as receivers for Whisper? We use Whisper, simple, because we don't want to be sitting at a computer doing this, because some of us may want to go out and get blinded by the eclipse. So we could set something up automated. And what I'm thinking is we use homebrew only equipment. So we have receivers that'll receive Whisper, and we have transmitters that'll transmit Whisper. And the idea is the receivers will see if we could hear the transmitters. And, in the end, we could correlate our data. And we use I've got a little slide here showing that, this is a great use for our DCR project, our direct conversion receiver that we've been put on the back burner. We have built Whisper kits in the past, so we could fire those up. We've got a little pup as a receiver. Some of us have a hack RF. We've got SDR. We've got lots of homebrew radios, rigs we could use. And same thing on the transmitters. Now I do have a Whisper Hans Summers Ultimate kit. But the problem is, if you're going to go by route of that, you got to have a GPS to get the time base. You got to get the time base. So anyway, that's my suggestion. And I'll just turn it over for discussion.
Yeah, I guess for some of us that don't have DCR or DCR yet, we could go with that little pup. Anything to convert it down to.
But we've got the eclipse isn't until April 8th. We've got a good December, January, February, March. We've got a good 4 months.
Oh, you could ugly style build a DCR in an afternoon. You probably, I bet you all of us, most of us would probably have the parts sitting on hand.
Or worst case, we could just get the parts and people build it, get their parts and build it on their own.
Yeah, that's an option.
Mm-hmm.
But anyway, I was just thinking, Whisper is easy. We could just set it up, leave it, let it run, and we could go do other things. We don't have to be chained to a desk. I
think you hit the nail right in the head there, Dave. Who wants to be sitting in the shack? You might want to be outside to experience it. And we're talking about how long does the eclipse last? 8 minutes?
It's about 6 or 8 minutes.
Yeah.
I think totality is about 4.5
Yeah.
in April, depending on where you are.
Yeah, it's of that order. It's several minutes, right? It's certainly not 10, 20 minutes. It's
Oh no.
several minutes. And the issue with Whisper is that duty cycle, because Whisper, by default, it's 20%. So it transmits, I don't know, in an hour, maybe 3 times. So you'd have to play around with the duty cycle to get at least 2 transmits in the when it's in place, right?
Dave, are you proposing measuring something?
No, just putting it on Whisper, and after the fact, all the data is collected on Whisper. We could go and see what we saw. We could get the signal to noise ratio. We could see what it was before, what it was during. Maybe before we won't even see each other, and maybe during, we'll get envious and we'll be able to see each other. I don't know.
Right. Okay. I got it.
Go ahead, Drew.
Well, I was wondering, Dave, what band you were recommending.
Well, it's going to have to be something with NVIS. So for me, I would think like 80 meters. And I know a lot of us don't have 80-meter antennas, but hey, you know what? Build an NFED. Just have a wire. Just have some little wire. This is just, an experiment. We don't have to have it perfect, or even 40. I know that Peter Peter et al., a lot of the other people, along with Peter, has had good experience on 40 meters doing NVIS. So maybe it's 40 meters. I don't know. But that's all details we could figure out, right?
Frank, do you remember, what we built? I think two Whisper projects. I guess one was a receiver and one was a transmitter. But for some reason, I think there was the transmitter 10 meters and what was the receiver? I can't remember now. Do you?
I think they're both 30 meters.
30?
Just a minute. I'm trying to remember. Yeah, well, there were 3 particular ones that would be fine for Whisper, and one year we built the receiver, and then next year we built the transmitter, or vice versa. The transmitter, it was a Whisper-10, but that did not mean 10 meters. That was the 10th anniversary of the homebrew group. And so, but the actual bands, I'm afraid I can't remember. With the other project was the Little Pop, and it was a receive only, but it was an excellent project for Whisper to receive. So it would be nice, really, to see some of these homebrew projects get the dust taken off of them and see them back on the air.
Go ahead, Kevin.
Yeah, sorry. I'm pretty sure they were 30 meters each. At least that's what I remember about the ones I have. Yeah, that's the one. But Dave, to your point about Kent Summers' ultimate Whisper thing with the GPS, I mean, the nice thing about that, like I have one as well, and I have the multi-band. So I was planning on setting it up like you kind of said, I have the GPS module. So I was planning on setting up and having it, and you can program it to run continuous, to transmit every 2-minute period, and then have it switch through the bands. Like you could run 40 meters, 30 meters, 20 meters, and then have it cycle back through, or whatever you want. But that's what I was kind of planning on doing. And so that would kind of tie in with what you were saying about, running Whisper and because I think Hamsai is collecting all the Whisper data as well during the eclipse.
Yeah, Kevin, I got called out one time. This was back when I was in Caledon. I started using Whisper to test antennas, and I had it set to 100% duty cycle to see the propagation. and I get a nasty email from a guy in New York going, "What the hell are you doing? You're wiping out the bands. I can't go on Whisper. I can't be seen. Why are you running 100% duty cycle?" He was screaming at me.
How much power were you running?
Maybe 100 watts.
Okay, well,
legal limit.
Okay, like I'm going to be running a third of a watt or whatever, right? So, and if you cycle through the bands, then you're only, and let's say you're using 3 bands, which is about all you can get through in the Eclipse. At a third of a watt, you're not going to bother anybody.
What's a transmit cycle like? Is it 2 minutes or
2 minutes?
A minute or
no? I'm pretty sure it's 2 minutes.
So one cycle.
If we so during the total eclipse, you're only going to get 1 cycle, right?
And there's going to be everybody there too, so everybody's going to be trying to jam into that.
Yeah,
exactly.
Yeah, exactly. Yeah, I mean, you got a whole what, 200 hertz to play with?
Yeah, no, but Whisper's good at the Whisper algorithm. You know, it's really good at getting all those weak signals that gets clobbered, right?
Exactly. And like I said, I'm pretty sure Hamsai is planning on harvesting that database after the eclipse, right? To check the paths and propagation and whatever.
There is a Hamsai project that, and I think you were there, Kevin. I can't remember if you were there last year with me or not. They do have, I think it's called the Grape 2 or something like that. They do have a board.
Yeah, no, we were at, we were at the presentation.
It's like hundreds of dollars, and I'm not going to afford that.
It wasn't cheap.
Yeah, no, it wasn't cheap.
Grape 1 was reasonable.
Yeah, the Grape 2 is a lot more expensive.
The other thing we could do is just build our own little, but again, now it's engineering, right? Build our own little transmitter that's going to send a blip and we receive it and we see whether we're getting it. And, you know, but again, now that's engineering.
We got 4 months. Is anybody interested in sitting in the shack for that time frame and just having a QSO party?
No.
5 minutes.
I want to see it.
So maybe just take your rigs and attach the antenna and sit out in the backyard. Is anybody interested in doing some CW or sideband sitting out in the backyard with the regular rig?
Yeah, probably. I would be.
Well, one question is, with the sun being eclipsed, the radio noise from the sun should be lowered. So why don't we just take a noise floor measurement through the eclipse? Crickets?
Well, no, you're right. There's an idea. Except in Drew's neighborhood, probably the sun is the least of his worries, right, Drew?
How do we measure that without being in the shack?
Is that a question?
Yeah.
If you're using Whisper, it'll be recorded automatically.
Oh, really?
The noise floor?
Yes.
You can do recordings with HackRF, you know, with the software. Do the recordings of the band of interest.
Yeah,
you can interpret it through the values that you're getting with the signal to noise ratio.
So I don't know where the sun emits most of its RF, but you could just listen to it on a speaker and just hear it. That would be kind of interesting too. So seeing the darkness as well as hearing the noise go down. A multimedia experience.
I think I'm going to take a look at that, you know, fire up the old HackRF, get the software going and just try, because you can record a wide swath of the spectrum in one go.
I'm sure, Peter, you could record, if you've got your PC interface, you could have your sound card recorded, right? Anything coming out of your sound card.
We've done it before. We've taken our HackRF and I forget the name of the software we've been using. Maybe Drew might remember, but we've done some recordings like that.
Doesn't it do something like 20 megahertz? Like a 20 megahertz bandwidth?
I forget, but you can do a good
The hack
chunk of it.
RF, yes.
Yeah, it's something
Yeah,
like that.
hack RF. We used Dragon OS, I think, and it transmits at 1 milliwatt.
I can't remember if I tried experimenting with the hack RF for transmit or not.
Well, I know that Asaf had us doing it, but I can't. That was with the GNU radio. I haven't tried it with anything else. He used to build the software we played with. GNU radio.
I've got mine working with HDS SDR, and
Oh,
it
I
works
think it'll
fine.
work.
I could
Oh, yeah.
decode Whisper. But
Absolutely.
so you
It'll work with all kinds of software. It's not specific to GNU radio, but Peter was asking about what we were doing with them, and I'm pretty sure that those were purpose-built demonstrations that he put together for us.
But we were using some other software. I can't remember what it was for recordings and all that kind of shit. But
SDR console.
There we go.
We could
But Dragon OS has all of that stuff. It's certainly the hack RF could do both.
So the hack RF would do it for a wideband, but we could all just pick a different band and just listen on a channel and record it with our phones and just compare afterwards.
Yes.
What would be cool with the hack RF is to record 20 megahertz of bandwidth. You've got it recorded, and then after the fact, you play it back. You could see what's on 20 meters. You could see what's on 40 meters. Because you've got the whole bandwidth captured. You could just play it back and filter out what you want to see.
Yeah. Now I have to find where my hack RF is.
Yeah, you could also go on the internet and just watch a video of the eclipse, but the point is to sort of experience it live. I mean,
I was actually going to watch it on CNN while I sat in my shack and transmitted FT8.
That'd be one way to get Antarctica.
I'll never get Antarctica.
Is there anything else we could do? Because there's also a reverse beacon, right? We could do, we could call out CW, have it automated, and it does a CW test message, and you can see who hears you. But you're only limited. There's only so many. What are they called? Spotters or whatever. Whereas Whisper, there's so many more people running Whisper.
Go ahead, Kevin.
Yeah, I was just going to say, Dave,
actually-
you have that ultimate Whisper thing. It does CW beacon as well for like the reverse beacon, right? It does all kinds of stuff, right? Different modes. And you can even have it cycle between them.
Is that a kit you bought, Kevin?
Yeah, it's one of the Hans Summers things. He's got, and I put mine in a little case, and it's like, it's amazing. It does all kinds of, and you can hook it up with a GPS. If you hook a GPS antenna up with a module, then it syncs the time and your location, so it figures out the grid square and everything, and away you go.
Huh.
And
you
it's
put
not
the link in the chat or something on that?
What
I'm not sure.
just go on QRPlabs.com.
Okay.
I don't have the link handy, but if you go on QRP Labs and go look on there.
Yeah, we'll do that.
Go ahead, Charles.
I guess my question is there any danger of dozens of other groups all trying to do the same thing with Whisper and basically just flooding the entire system such that nobody's getting through?
Yep.
Well, I bet you it's going to be busy.
What I was kind of thinking that's why I do FT8 is because it you can watch your own propagation on PSK Reporter, but it's going to be so busy anyways. You're not going to be interfering with other people. They're all there.
I mean,
Whisper.
From the Hamside presentation at Dayton last year, they want as many people on the air as possible. And if you lose a few reports, so what? They just want to get as much transmission as possible to map the response of the eclipse. That's what I gathered from it.
Was Whisper their preferred method?
And no, I think they're harvesting Whisper, reverse beacon, FT. Like they're doing whatever they can. I think they're going to go in and grab the databases after the fact.
Right. Okay.
And the nice thing about Whisper is that, because Whisper, it doesn't even have to be on the band. You don't have to hear anything. It'll pick it up. You could be right below the noise floor. That's why they transmit for 2 minutes. They transmit to, over a longer period of time because they have a lower signal to noise ratio. And they could recover the signal. So even though the band's full of data, unless two people are on the exact same frequency at the exact same time, then maybe you get clobbered. But Whisper is really good at pulling signals out of the noise, right?
Yes. Yeah, it's unequal.
This might be I don't know if it's in the spirit of what they're looking for, but my understanding is that they're wanting to track different modes of propagation and what effect the eclipse has on them. Would it be valid to set up an SDR where I'm listening to 3 or 4 bands, listening to beacons, existing beacons, and get a baseline of, well, this is the signal strength before the eclipse, and then record the signal strength through the eclipse and then after the eclipse? Because, for instance, if I'm listening to one of the beacons in California on 20 meters and it's an S7 here, the eclipse starts, and track the reception as it degrades or improves during the eclipse.
Yeah.
Is that a valid thought or not?
Yes.
Sure.
Actually,
That's
Dave, I think
exactly-
that's the essence of it.
Yeah, that's exactly where it was going. You start the transmitting like an hour before the eclipse, and so you see what you're getting, and you may not even get any propagation because the band might be shut down. Because if you look at what happens during the eclipse, it's simulating night, so the atmosphere, the layer shifts, and so the bands that are open at night opens during the eclipse, and that's what HamSci wants to see. Now, the key thing here is that I guess the goal: are we doing this for HamSci, or are we doing this for ourselves?
Yes.
Because for me, I'd like to do it for ourselves. If HamSci benefits from it, great. But I think as a group, this is an opportunity for us, as Frank said, use our homebrew equipment and use it, put it to use, and see whether we could find out something about the eclipse. And if HamSci could use it, bonus.
How does HamSci scrape the data?
From the reporters, from the WhisperNet.
Oh,
They
okay.
go on WhisperNet and they scrape it, and they scrape it from the reverse spotting net, RBN, and they scrape it from all over the places.
Well, I definitely would be interested because I've been running an AndFed for the last few years, and I was intending to find out what my propagation is on it. So we got that Park Whisper unit. I'm going to put it on there and see what happens.
Is there something else we could do? Is there something else we could do that's simple? Again, we don't want to go and end up engineering something over the next 4 months. I think we've got enough on our plates. Is there something else we could do that's simple, and we could learn something about the eclipse?
Well, the only thing that would be simple, Dave, would be to take existing rigs that we already have and set up outside. So you can be outside to observe the eclipse, but also operate with your gear. And, instead of we're talking about early April, so who knows exactly what the weather's going to be like. So, even if you set up something in your garage so you're dry and stick the antenna in your, whatever. But, there's an idea. The next idea would be, is there something if we do that kind of thing, then that opens up sideband CW as well. Do we try and do something between Eastern Ontario and the Western Ontario where you guys, the Carex versus SOAREX kind of thing. Well, not versus, but QSO party.
I did do some experimenting on the last one.
Like start an hour before the eclipse, and then.
Yep.
What about NVIS? I'm not sure about this, but an ionosound, you basically send a pulse up, a carrier wave upwards into the ionosphere and look for the reflection. And then as the eclipse moves over, as the edge of the eclipse moves over the face of the Earth, the ionosphere will change and you'll see that in a disturbance wave.
Well, it's interesting you mentioned that, Hassan, because I was thinking about that project that Dave did a few years ago. Remember that one, Dave? I think you got it working on the bench or a simulation, but never actually got it out in the field.
It's just the noise. It was just a signal to noise issue because I was transmitting, only a watt or so, and the problem is noise. The antenna you got, but it was working fine. If I didn't have noise on the bench, I would resolve it easily between the speed of light going up and coming back. But the other thing I was going to suggest, I think, Peter, you mentioned, someone mentioned Kingston. The other option we could do is we could have our own party. We could have a 1 day at the eclipse. We all get together, go to a park, go somewhere, and we all get blinded together.
I was thinking a Carex, SOAREX, QSO party.
Yeah, no, but we could certainly go get together somewhere, set up some equipment, and we just hang out. So we could do that.
Yeah, never mind the protective eye gear.
Details.
I mean, if Donald Trump can do it, we can do it, right?
That explains a lot. He's seen too many eclipses.
No, the sun might create some laser imagery so you guys can actually solder SMD stuff.
Actually, this is recorded. We should watch what we're saying about politics.
Go ahead, Drew.
Well, I was just going to suggest that like Hassan mentioned NVIS and the like, and I think that's kind of spot on. And I was thinking a 40 and 80 meter NVIS whisper, just sending. If you can only get one transmission in, you're going to have to pick your band. But an NVIS antenna is pretty easy to put up. Even if you're in the city, you could put up a 40 meter. And it's only a few feet above the ground. We've had a lot of success with them out to 1,000 kilometers. I was just thinking that as a parameter, we don't have any standardized anything. So any measurements we take are going to be strictly relative anyways. And based on assuming the propagation conditions continue to be, more or less stable over the 2 hours we're playing with, which may not be true. But 40 NVIS and 80 NVIS takes out a lot of those vagaries you see on 10 to 20.
And worst case, you could build an 80 end-fed antenna, and I'm sure you could load that up at 40 because it's going to be a full wavelength. I guess, right?
Well, I actually have a plan for a. I actually have a plan for a. It's a garden end-fed, but it does. It's got a coil. It's got a coil on it for 80, so it's only 66 feet long, 70 feet long.
And so we have time. I guess it's just a matter of getting an appropriate antenna, right? That we know works.
And I think Peter reminded me that there was a Carex note from Mike about a particularly interesting 56-to-1 end-fed transformer experiment.
Yeah, something like that.
Yeah.
And I've actually built. I built a few of those. I think I ordered that toroid. That antenna intrigues me because he was able to demonstrate quite cleanly that it was a very efficient antenna at those frequencies, or it was the better of the selections. So I was going to play with that. I mean, it would be a good project, I think, for a group to build a bunch of these things and try them all with standardized kit and see how they work.
Looks like Dave's getting a head start.
Oh, he's already run off to the basement to get his toroids?
No, he's already got the wire already coiled up, ready to go.
Well, that figures.
Remember one day at Eric's cottage? I had two.
That was
these
4
are-
days at Eric's cottage.
Yeah, it was. These are from QRP guys.
Yep.
One's a long wire antenna, 40 to 10 meter on an antenna plus, and this one's a QRP guy 40, 30, 20 end fed antenna, and it cost them next to nothing.
Yeah.
It's just a board. You have to supply the wire.
Well, these are inexpensive antennas.
Yeah, I think we tried them out on the reverse beacon network, if I recall.
Yeah,
I remember that.
It didn't work really well, but I don't know. I think Kevin ran his. He had an antenna. He ran it, and I think
I did
got
too.
better.
I think I beat you, Dave.
Yeah, I can't remember. All I remember was square waves.
Oh yeah, I remember that. Yeah.
Yeah, we got to do another 4 days at Eric's cottage. All this talk about antennas, and if you noticed, he who must shop has been very quiet. See,
Yeah, he's
no
the guy
antennas,
that's got it.
nothing to talk about.
I'm just absorbing. That's all.
We should go check out.
Radiating, not absorbing.
Got a ton of antennas.
Calculating. Deciding who's first.
So maybe, Peter, we should just ask who's willing to participate in this. Whether everyone thinks Whisper's the way to go or what. Maybe we could just find out if there's interest. Because if there's no interest, then we just kind of leave it. But if it's interest, we could maybe more formalize what we need to do at another meeting. Maybe we have another working session and we kind of better formalize how we're going to make it work, how we're going to do it.
Yeah, I could use Group IO as well to do something to communicate back and forth as well in between instead of waiting for the meetings. But I think for me, what I'll do is I'll dig out the Whisper stuff and see if I can get it up and running and look for my hack RF. And I think at a minimum, I might plan for setting up the radio out in the backyard somewhere as well, and go that route. I'd be interested in some kind of a little bit of a CAREX / SOAREX kind of QSO party if enough people want to do that.
Because I think what I'm gonna do is I'm gonna take the Phoenix, I'm gonna interface it to my computer. I got time. It's not gonna take much. It's just a sound card, really. Just connecting it to a sound card and manually tuning it, and just running Whisper, transmit Whisper, and just get that working. So I'm thinking that's what I'm gonna do, because then it's 100% homebrew radio that I'm going to use sending Whisper.
Yeah.
The link that I provided in the chat there is if you want to do some passive recordings of AM broadcast, you can have a look at that. That they're looking for INQ data during the eclipse, before, during, and after.
Who's that? Hamside?
Oh, that's Hamside. Yep. Just saying.
Interesting idea.
How would you record INQ? Wouldn't you have to have some kind of phasing rig to do that? Because your speaker is going to mush it all together, right? Because it's left and right channels. Unless you could save it left and right channels.
Use the hack RF.
The what?
Or an SDR of any kind, right?
Yeah.
You don't need
Any
the hack
SDR,
RF for that.
Yeah, true.
I mean, a
sorry,
$30,
it's
a
saying
$20 SDR can do that. Just sit it in the corner.
Would it save your INQ as audio file? That's what I'm saying.
If you're using
saying
a Raspberry
record it.
Pi to listen on it.
it seems to. They're saying that there's a number of common ones like the SDR Play, you know, the RSPDX, Win radios. If you have the money, an ELAB. But yeah, a lot of them, RF Space, Net SDR, Cloud SDR, all of those.
Cheap dongle. Cheap dongle would do it.
You can.
If you're talking receive, GNU Radio is pretty easy to use.
If you pull down a copy of Dragon OS and you have a Raspberry Pi sitting around, there is a colossal amount of software on that operating system that will do all of this. It's a remarkable resource. And Raspberry Pis are getting cheap now. Everybody wants a 5, so you can buy a 3 for nothing. Just sit it in the corner and record. That's I use them a lot for stuff like that.
They
Just pretends it's me. It's the village idiot in the corner.
Do they have a microphone?
Does anyone?
No, they don't have a microphone.
But I do like the idea of transmitting and receiving within the group, you know, across the path and, you know, before, during, and after.
Yeah.
Not a bad idea.
Well, if
how
we're
many
in
people are
Kingston, I guess it doesn't matter where we transmit to, does it?
No. Yeah. Just go back and do roughly just do what we were doing before. When some of our Monday nights.
Is the path over top of Peel?
No, we're north of the path of brutality.
You're north of it, okay.
It's going
because it's right on top of us, eh?
Yeah.
Yeah, the center line's going Leamington all the way Kingston and out, and then but then, you know, it's not going to be a narrow thing that you got to be in Leamington to see it.
No.
You could be,
no.
You know, 60, 80, 100. I don't know what the distance is, and you'll still see the entire eclipse, right?
Well, you know, that raises an interesting thing because as it comes across, Frank and us in Kingston are on the same line.
So we can rent out our group.
Because I mean, Frank's in the Berg, right? So that's pretty close. So that would be interesting to see what happens to his propagation and our propagation as it proceeds along.
Yeah, that would be interesting.
Because, you know, if you're dead line with us, Frank, we could actually find, you know, I suspect what will happen is that you will disappear and then come back in. And if we're transmitting to you on a 40 or 80 NVIS, that even if it's a whisper, that we'll see that. I prefer to use FT8 or FT4 because there's more transmissions during that period.
It can't.
And we can pick our own frequency too, eh? We don't have to use the FT4 frequency. We can use our own frequency.
Yeah, but FT4, FT8, that's you got to be in front of your computer. That means you can't be outside, right?
Why not just go?
No, actually, I run my system completely by remote, Dave. I do it all through a Raspberry Pi and VNC. I never sit in front of my radio.
But okay, you still you have to be in front of a computer to make this work, whether it's outside, inside.
No.
The whole point, what I was saying is,
hey, Dave.
I run it off my phone, Dave.
Dave, we had a guy here. One of our local hams here was in the hospital having an operation. While he's in recovery in the hospital, he's using his iPad to connect to his remote station.
Yeah. Peter, I understand that, but you still have a piece of equipment that you're looking at.
Oh yeah,
whether it's an iPhone or phone or PC, you still got something in front of you, right? That you got to go use, and that's taking away from you getting blinded by the eclipse.
I like the idea of setting up my rig outside and going inside that.
Well, I agree. It would deprive us from watching prominences, but I think it's likely that it's going to be cloudy because this is Kingston, and we never see anything in the sky when it's good.
That's true. That's a good point. Yeah, we don't
I
know what
spent
the weather's
so
going to
many
be.
months.
That's why I'm going to.
I will tell you how many months I spent looking for Comet Kahutek in the 70s, and I swear by the fact that we have clouds that are shipped in about an hour before.
Hey, Phil
That's why I'm
reported
going
all
to
those
Texas.
satellites that went by the other night. Didn't you see that, Drew? We had a clear sky that night.
So
Too
we should
cold.
have a plan A and a plan B. So plan A is
Or
if
both.
it's right, if it's clear, and plan B is if it's cloudy and we can't see anything.
Drink beer and
We can still get blinded.
Well, I know I haven't got the astronomy equipment to really make hay on in terms of prominences and that sort of. I mean, I'd love to have an alpha filter and an 11-inch and all that stuff, but it's not going to happen.
But my son has got a whole bunch of cameras. I'm just going to get a camera and point it at the sun and see what you see. I'm sure eventually you're going to see a big blob, and all of a sudden you're going to see it disappear, right?
Are you going to put a filter on it?
Well, once the eclipse comes, it's going to be a total eclipse. You're not going to see anything, so the camera is going to capture that. And then as soon as it comes off, you're going to see this nothing. The camera's going to see nothing, right? But yeah, you can put filters and all that. I think Eric's old man has got all kinds of filters for viewing solar activity, right?
Sure, yes.
And I've got welding filters and stuff, but
absolutely,
yeah.
yes. Yeah.
But anyway, that's the detail. I haven't figured out how I'm going to observe it, but I'm going to observe it somehow.
Well, I must admit, I'm on the QRP Labs website right now, kind of thinking that whisper transmitter would be a good thing to set up just to run while it's all going on.
Well, over the next few weeks, okay, I think our regular meeting in December is canceled due to proximity to Christmas. We could say maybe the regular meeting, or I guess maybe even the mixer in January, or the regular meeting, one of the two, kind of report back, because that gives everybody enough time to dig out, dust off whatever equipment we've got in the shack to do these things, whether it's Hack RF or the Whisper project, et cetera, and then maybe come January we can say, okay, might have a better idea what individuals want to do.
I think, Peter, let's take a step back, and we have to make a decision to say, are there enough people interested in doing it? I'm going to be doing it, but is this something that other people are going to be doing? How many other people are, because that's what I'd like to know, is how many people are going to participate in this?
Well,
I think that's
definitely going to try.
I like to.
I'm going to try.
I'm in.
I'm in.
I'm in too.
Yeah, so okay. Put my hand up. There, I'm in.
Oh, yeah, we could do that.
Look at that.
Actually, I've got a pretty sweet deal. I've got an Airbnb arranged at an Alum Avenue in Kingston.
Well, you know what's funny about that?
Going to be a sunny day, so.
We received a note from the Picton Club. They were contacted by the police and the fire department because they want some kind of help on communications. They're expecting something like 40,000 people in the county. So this area is going to be loaded with crazy tourists walking around with 3D glasses on.
That area's loaded with crazy people all the time anyways.
Well, not as often as what I'm here, but
No.
Yeah. Ophthalmologists in Kingston's going to be busy.
Well, I was going to say, I actually have some welding glasses and stuff like that I tried. And you want to try it a few times before you try it during an eclipse, because it's shocking how much glass you have to have as a welding glass to make a difference.
Forget that. I'm going to be bringing cases and cases of white canes to sell.
Good idea. Anyway, it sounds like there's a lot of interest here too at the club at CAREX. There was a lot of interest about this as well. So I suspect we could probably get 20, 30 people all pinging radio signals around. Could actually cover almost all the bands.
Yeah, I actually tried to get my whisper thing working, and then I realized I don't have a GPS.
Well, the surf chips are cheap.
Yeah, I'm just gonna have to. We got time, so I could play around. That's another option, because like as Kevin said, it's easy. You just get it, set it up. You could even take it outside, throw a wire in a tree, set it up, and fire it to go,
and walk
and
away.
just leave it.
Yeah. Absolutely.
But
You haven't actually got much time.
And that's just a transmitter, right?
Yeah.
Well, Dave, I've got an unbuilt GPS kit.
I got literally about 20 GPS chips here, because for like flying aircraft for my flight controllers, I got all kinds of GPS chips. So just a matter of finding one that's going to be compatible with that. I think it's, as long as it's I think it's a NEMA. I think the output's NEMA. As long as it's a NEMA compatible, it should be fine.
Yeah, it's 4,800 baud.
Yeah, but I think there's NEMA 1, 2, 3. There's a bunch of
they're all the
NEMA.
same. It's all most of the surf chips put out NEMA 0183, and they're pretty standard.
Yeah.
So you should have no problem with that. Would that whisper transmitter, is that what it takes in? Is NEMA 0183?
I don't know. I'd have to check the docs to see what it is, but I'm pretty sure Hans Summers is a pretty smart guy, so I'm sure he's not going to lock it down to one specific, implementation.
Well,
so
it's just the most common.
Yeah.
Yeah, it's just the most common one. I mean, 0183 has been around forever, and the new one is aggravating because it's, it makes everybody buy new stuff, the new version. Either way, lots of time to plan. Sounds like fun.
Okay, so it's, are we thinking that we're going to do Whisper then? It's just a matter of figuring out how we're going to do Whisper, whether we're going to build, a Hans Summers kit, or we're going to use our own home. How many people have got homebrew radios that they could use to run Whisper right now?
Well, I got the Park Whisper transmitter, Whisper 10 or whatever it was. That does, and we were right earlier when they said it was on 30 meters. That's what it is. I checked. So
now the other thing about 30 meters, doesn't 30 meters shut down at night?
Well, it'll be nighttime when the eclipse goes over.
Right, so that's what I'm saying. It would be the opposite effect. You would be seeing it open during the non-eclipse, right? And then during the eclipse, it would shut down.
And then it should come back up, or vice versa, whatever. Anyway, that's what I'll probably take a look at that. And then I'll also take a look at seeing if it wants to chew the fat during the eclipse. But I would set up outside.
You'll have to use an umbrella, Peter.
Well, worst comes to worst, I'll set up out in the big shed I got out in the backyard, and I'll just run a patch cable over to my antenna. Not a problem.
Yeah, that's a good find, Hassan. That's going to tell us exactly what we need in terms of the differences between night and day, and with the sun and not the sun being there. That's pretty good.
Yeah, there's some ideas there. They talk about radio amateurs, and a lot of what they were doing was just trying to promote the hobby during the eclipse. But there might be some interesting ideas.
Well, if
that's good. That's a good. I'm going to take a look.
Frequencies from 80 to 30.
So, okay.
Yeah.
That's good. So good. Peter, I think the round table is a success.
I think this one was not so much a roundtable as this one was just there was enough, I guess, interest that everybody was pretty much threw their 2 cents worth in, which is good.
Yeah, and we can carry it into the next meeting. If people have started working on it, I'm gonna pull out my the Park Whisper thing and hook it up. I want to check my antenna anyways, and just see
And
how.
Also, too, Ken, this is a perfect that's why I was asking you recently about what's the status of the DCR. This is a perfect thing for the DCR because it's just got audio, and you just take the audio and you feed it into Whisper, into your sound card, right? That's all you got to do, right? And your PC will decode the Whisper for you. So it's simple. The DCR is just a simple way of doing this. And it's a relatively simple build, right? So someone who doesn't have a homebrew radio that wants to have something homebrew, DCR.
Yeah.
All right.
All right. Well, we can discuss that further. Anyways, we've got 9:15 coming up here. We can carry the discussion over to the next meeting, or we can have discussion on the groups IO.
Yeah.
Okay. Well, gentlemen, it was a good night. We actually had at one time, including the recording, we had 19 people tonight. So very good, very good. Go ahead, Howard.
No, sorry, I missed that. I was pushing the chat button.
Okay, Dave. Okay, excellent. Okay, gentlemen, bid you a good night, and we'll see you on the groups. Take care, everybody.
Good night, everybody.
Thank you. Good night.
73
Thanks, Michael, for the presentation. Enjoyed it.
Thank you.
Very good.
Yeah, that was good, Michael. Thanks.